In this video, you will learn to identify congruent and similar shapes, and you will also learn to use the properties of congruent and similar shapes to find an unknown measure. So let's begin with congruent shapes. Now, two shapes are congruent if they have the same size and the same shape. We'll get some examples of that here in a moment. The symbol we use is going to be an equal sign with a little squiggly line above it. So it looks like this right here. And we can say that two polygons are congruent if the corresponding angles are of equal measure and the corresponding sides are of equal length. All right, so in this next slide, we see here two triangles. They are congruent because they are both the same size and the same shape. All right, they're identical. So with these congruent polygons, we said we can take it a step further and state that each side would be the same length, or the corresponding sides at least would be the same length, and the corresponding angles would have the same measure. So let's take a look here in more detail. So these two triangles we would say are congruent. We can state this in math notation as right here. You have triangle ABC is congruent to triangle DEF. Remember, when naming polygons, we can use a symbol. If there's a symbol we can use, like triangle, there's a symbol for triangle. There may not be a symbol for, like, a pentagon or hexagon, but some shapes there's a symbol we can use. And then we just list out the different vertices. So all the vertex here, A, B, and C, we can list them out, and that would be your polygon. All right, same thing over here. We list out the letters D, E, F, put them over here next to the triangle symbol. Now take note that the order does make a difference when you are comparing or saying that two shapes are congruent or even similar, as we'll discuss in the next part of the lesson. So we see here A is in the top, D is also on the top. Those are corresponding vertices. Okay, so if we put A first, right here, so for triangle ABC, in the other triangle, when we write it out, the corresponding vertex D needs to come first as well. So if A comes first, D must come first. And then we see that B corresponds with E. They're both in the bottom left corner. So because we put B second right here in this triangle, we need to put B second here when naming this triangle. And then we see that C corresponds with F. We wrote C third, so F would have to come third as well when we write this out. So if we were to write the first triangle a little bit differently, let's say we had triangle BAC, and we wanted to say that's congruent to the other triangle. Well, B came first, so E must come first when naming this other triangle. A comes second, so D must come second when naming the other triangle. And then C came third, so then F must come third as well in that other triangle. All right, so that is another way we can express the same statement, that these two triangles are congruent. So we've mentioned a couple times that with congruent polygons, that the corresponding angles must be the same. What we mean is that right here, we have angle A, and that would be congruent to angle D. All right, those are corresponding angles. Those two angles would be congruent, or meaning the same measure. All right, they're the same size. So those two angles would be the same measure. We also would know that angle B and angle E would be the same measure. Those are corresponding. So those we can say are congruent as well, right? Same size, same shape. And then angle C would be the same measure as angle F. So those would be congruent as well, because those are corresponding angles. So those corresponding angles would have the same measure, or they're congruent. And then the corresponding sides would also be congruent, or the same length. So like side AB over here would be the same length as side ED over here. So those would be congruent. They're the same measure, same length. And then BC, the bottom down here, would have the same measure as EF down here. So those two sides would be the same length as well. So those would be congruent, same size, same shape. And then the third side, AC, would be congruent or equal in measure to side DF. So we can say that those are congruent. They're the same size, the same length. So that's how congruent polygons work. Now with congruent polygons, we can also use given information to find an unknown measure. So for example, if we are told that measure of angle B is 90 degrees, so this is 90, measure of angle F is 70, so this angle right here is 70 degrees. We can use that information to find measure of angle C, measure of angle E, and measure of angle A. And we could also for angle D as well. Alright, so we can use the fact that the triangles are congruent. So if this angle F is 70 degrees, angle C must also be 70 degrees. Alright, so that is because they're the same measure, because they're congruent. Those bottom right angles would be the same. Alright, and angle B is 90 degrees, so angle E right here would also equal 90 degrees, because those are the corresponding angles. And then to finish off, we can find angle A and actually angle D at the same time. They'll be the same measure. And we could do that because we know that a triangle has 180 degrees total. And right here we have 90 degrees and 70 degrees, which gives you 160. So that's 160, and then there's 180 total. So if we take 180 minus 160, that gives us 20 degrees remaining for this angle up here. So the measure of angle A would be 20 degrees, and as would the measure of angle D. That would also be 20 degrees. And by the way, just a reminder, the M in the front, I've been saying it but didn't really explain it. M means measure, so the measure of the angle. So the measure of the angle will be in degrees. So we can calculate missing angle measures by using the fact that with congruent polygons, the corresponding angles are congruent. And we can also find missing side lengths. So let's say, for example, that AB is 5 centimeters. So that'd be this side over here. And we're told that DF is 12 centimeters. That'd be this side over here. And the question is to find AC and DE. Well, if AB is 5 centimeters, then DE would also be 5 centimeters, because those are both the left side of that congruent triangles. And then if DF is 12 centimeters, then AC would also be 12 centimeters, because those are corresponding sides of the triangles. So we have our answers. We have AC would equal 12, and then DE would equal 5. And that's our answers for those missing side lengths. So we've worked with congruent polygons, and next we're going to talk about similar polygons or similar shapes. So for similar shapes, we can say that two shapes are similar if they have the same shape, but not necessarily the same size. It could be the same size, but most of the time it would be a different size. An example of this in real life would be maybe like a model car, okay, where everything is the same shape as the original car, but it's not the same size. So those two cars would be similar. They're not congruent. And the symbol we use for similar would be kind of like the congruent sign, just without the equal part. So the symbol we use would be this little squiggly line right here. So it looks kind of like a worm, just kind of like that. So congruent has an equal sign with it. All right, so because congruent has the idea of being the same or equal size, whereas similar shapes do not have equal size. They're similar, but they're not equal in size. All right, so you don't have the equal sign with the similar symbol. And we would say that two polygons are similar if the corresponding angles are the same and the corresponding sides are not equal but proportional. They're in equal ratios. So an example of this would be right here with this picture. We have here two similar, it looks like trapezoids. Okay, it's two similar polygons. All right, and with this, with the notation, we can say that these different quadrilaterals are similar by naming this quadrilateral over here. We can name that as WXYZ. So we have quadrilateral WXYZ. There's no symbol for quadrilateral, so we just write out the letters in order. And then that's similar to, here we see the similar symbol. Then we have O, P, and M. And again, the order makes a difference when naming that second polygon, because if we do a W first, when naming the first polygon, we need to use an O first over here. Those are corresponding. So W comes first, O must come first. X comes second, P must come second over here, because those are corresponding. Y comes third, so then N must come third. And then Z comes fourth, so M must come fourth when writing this out. So just make sure that the second polygon follows the same order as the first polygon. And it's worth noting as well, when naming this first polygon, that you must pick a letter to start with. So like, for example, pick Z, and then either go clockwise or counterclockwise around the polygon with the letters. So if we start with Z and go clockwise, we would have Z, then Y, and then X would be the next letter, and then W would be the last letter. So that's another way you can write the same polygon. All right, or you can go counterclockwise and get Z, W, X, Y. That's another okay way of writing that polygon. What's not okay is if you pick a letter and then jump across to a different vertex. So if you were to do, for example, Z, X, Y, W, you can't do that because you jumped across. You have to keep going in order around the polygon. All right, so make sure you're aware of that as well. So with similar polygons, we said that the corresponding angles will still be congruent. So for example, angle W right here would be the same measure, would be equal measure to angle O. So they're congruent, they're equal measure. All right, so then angle X right here would be congruent to angle P over here. Okay, those are corresponding, so those would be congruent. They would be equal measure. And then angle Y up here would be congruent to angle N right here. Those are both corresponding. They're going to have equal measure. So they're congruent. They're the same size and shape. And then lastly, we have Z and M would be congruent. All right, because those are both in the top left corner. So those would have the same measure as well. So that is one part of similar polygons, which is where the angles, the corresponding angles, are congruent. And the second part of similar polygons has to do with the sides. Now the sides are not congruent, obviously. They're not the same size, right? WZ is not the same size as OM. But what is true is that the ratios will be the same. So if you compare WZ and OM, those are corresponding sides. If you write that as a ratio, so the length of WZ divided by the length of OM, that ratio will be the same for any pair of corresponding sides. So if you look up here at ZY and divide that by MN, the other corresponding side, if you divide those two sides, it's going to be equal to the same number, the same ratio. And then you can continue that with the other sides. So YX corresponds with MP. If you take YX divided by NP, that again would have the same ratio. That'd be equal to the other ratios. And then the bottoms, WX and then OP, those are going to be corresponding. I guess I shouldn't technically use the lines because that means congruent, but those are the corresponding parts. That's what I was trying to go for. So those are corresponding. So if you divide WX divided by OP, then that ratio would also be the same as the other ratios. So the side lengths are not congruent, but the ratios of the corresponding sides are going to be the same. So looking at the angles, okay, so we can use similar polygons to find a missing angle measure. So in this example, if you're told that the measure of angle W is 70 degrees, so if this is 70, measure of angle M is 110 degrees, and measure of angle Y is 90 degrees. So this is 90. Our objective is to find the other angle measures. So angle Z, angle X, angle N, and angle O. All right, so to do this, realize that the corresponding angles will be congruent. So if angle M is 110 degrees, angle Z would also be 110 degrees. And then if angle W is 70, then angle O over here would also be 70. Those are corresponding angles. And then if angle Y is 90 degrees, then angle N would also be 90 degrees. All right, so we've answered for angle Z. We said angle Z is 110. We just found that up here. Angle X, we can find that. Okay, so we don't know angle X or P, but we do know that a quadrilateral has 360 degrees total. And so right now we have 70 plus 110, that's 180. 180 plus 90 is 270. We have 270 degrees used up right now. So the remaining angle you can find by subtracting the two numbers. That gives me 90 degrees. So angle X would be 90. All right, so angle X would be 90 degrees. So we found that one. Measure of angle N, we found as well to be 90. So angle N is 90. And then measure of angle O, we found to be 70 degrees. So we have found all the different angles. And if we wanted, we can find angle P. Angle P would also be 90 because angle X over here is 90. So that's how you can work with angle measures with similar polygons. And to finish off, we're going to work with side length. So again, we have the same picture. We are told that these shapes are similar, so the angles are going to be congruent, and we know that the corresponding sides will be in the same ratio. Okay, now what if you plug in actual numbers here? So let's say we have these dimensions. So we know that WZ is 6, ZY is 7, WX is 10, and we have 3, 3.5, 2, and 5 for the other lengths over here. So we can find the ratio between the two different polygons. So to find the ratio, we just pick two corresponding sides, such as 6 and 3, and divide. 6 divided by 3 would give you 2, or 2 over 1. And the ratio for similar polygons must be the same for any two pair of corresponding sides. So if you were to look at the 7 right here and the 3.5 right here, those are corresponding. And if you take 7 divided by 3.5, that again would give you 2, or 2 over 1. And then the bottom, we have 10 and 5. Those again are corresponding. So if we were to divide 10 divided by 5, that again would give you 2, or 2 over 1. So we have concluded that the ratio is 2 over 1, or 2 to 1. By the way, this notation right here, the 3 dots, that means therefore. All right, so we found the ratio, and we can use this ratio, we can use this pattern to find a missing side length. So for this lesson, we'll keep it basic, where the ratio is not anything too complicated. It's not a weird fraction. And we're trying to find now this missing side length of WX over here. All right, so the ratio is 2 to 1. So we see the pattern is you take 7 divided by 2 to get to 3.5, or 10 divided by 2 to get 5, or 6 divided by 2 gives you 3. So the question is, what number here divided by 2 gives you 2? and that would be 4, right? 4 divided by 2 is 2. So we know that this missing side length must be 4 to keep that pattern going. So that's the basic idea. We're not going to get into more difficult problems for this lesson, but that's the idea for finding a missing side length. And that concludes our lesson for today. We will see you next time.